Boyle was a scientist in the 17th century. Today he is considered the first modern chemist for all his contributions to our understanding of chemistry principles and his methodology of the experiments he did. He is best known for Boyle's law, which describes the inversely proportional relationship between volume and pressure. You can see this relationship summarized in the mathematical representation of Boyle's law. Here we see that volume is the denominator, so as the quantity V increases, pressure will decrease, and vice versa. You can rewrite the equation with pressure as the denominator, and you will still find the same inverse relationship is true. Volume is basically the amount of three-dimensional space an object occupies. We'll take, for example, a cup of water. The water you pour into the glass takes up a volume. When we look at Boyle's law, we're thinking of volume as either being liquid or gas. Another important concept for Boyle's law is pressure. Did you know that if you have a pile of coal and you put a lot of pressure on it, you can actually end up with a pile of diamonds? That's really impressive. So pressure essentially is force per unit of area. Now that we've gone over what volume and pressure are, let's take a look at an example of Boyle's law in your everyday life. Have you ever caught yourself daydreaming, maybe dozing off, looking out your window and you see an airplane flying above? Well, they take off all the time, and they're really cool. Let's take a look at this takeoff closely. If you have been on an airplane, you've probably noticed your ears obnoxiously pop during the takeoff and landing parts of the flight. While airplanes are really cool, scuba diving is also something very unique. Have you ever had the chance to go scuba diving? While you may have not gone on an airplane or scuba diving, you've probably played with balloons before. Boyle's law states that if temperature is held constant, as the pressure of the gas increases, then the volume of a contained gas decreases. The opposite is also true. In this picture, you can see a graph showing this inverse relationship in the right-hand corner. Check it out. Now that we have our balloon inside a vacuum container, let's see what happens when we change the pressure around it. Let's decrease the pressure. Well, based on our relationship we determined before, actually, the volume should increase, which we see here. The balloon seems to inflate itself. Now, let's try increasing the pressure. Well, if we increase the pressure, the volume should decrease, which is exactly what we see here, the balloon doing inside the container. And now we've removed it from the container, you see it's still the original volume it started out with. Pretty cool, right? Let's see this again. This time, when you see the video, think out loud and see what's going on. Is the pressure being increased or decreased? Check it out. Whether you're scuba diving and notice the bubbles changing size as they approach the surface, you'll probably notice that it acts just like the balloon that we saw in the vacuum container. Or you're taking off or landing in an airplane and notice your ears pop from the change in pressure from the surrounding air. You should now think, this is Boyle's law in action.